Hi everyone, I'm Matt Source, the Advanced Services Project Manager here at Phoenix National Laboratories, and this is another episode of Tech Talk. Today we're going to be talking with Kyle Fleege. He is the Project Manager for our Testing Mechanical Lab, and we're going to talk about everything the Mech Lab does, what Kyle does day to day, and just all of it. So, hope you guys have a great time. All right, Kyle, how about you introduce yourself to everybody watching?
As you said, I'm our project manager. So what I manage for P&L is our destructive testing laboratory and then our GPR services. My background, grew up in the Midwest in Iowa, went to school at the University of Notre Dame, got my degree in mechanical engineering, and then moved out here, worked in construction for a little bit, and then started at P&L. And then have done a little bit of everything. When I started, I did our actual physical tests, then went into more advanced stuff, reporting, and eventually into like project management, which I do currently.
Nice. So a lot of people know P&L for NET services because that's where we're probably the most traveled right there. What mechanical services do we actually offer inside the lab? What can we handle here?
So it's a lot.
It is a lot, but I mean, if we could like layman's terms, like blanket it, where would you blanket it at?
So like our main machines we do work with are like universal test machines. We use instrons, which allow you to do compression, tension, custom tests. It all just depends on how you can hook up to the machine.
Yeah.
So we do a lot of elastomers, metals, and like plastics testing. Anything from tension setups for just simple tension strength, yield strengths, to other like shear or bending tests we've done like concrete 3-point bending tests for some customers. But yeah, they're general machines set up to do a whole bunch of different methods. It just normally people will approach us with a test method and we'll give it a read through, see if it's something our machines can do, and if it is, like we try to help them out, get them a quote or do whatever we can to be able to run their tests.
Now, a bulk of the projects that come through our bag is it's rubber bearing pads. So what would you say like ratio wise between bearing pads to miscellaneous random stuff? What would you say would be that?
It's probably like 80-20.
80-20?
Yeah,
Okay.
Maybe even like 90-10. So like the bulk, like you said, are like bearing pads, which go into bridges, overpasses. And we do a lot of that for the manufacturers, do some testing direct for DOTs, and then contractors. So we get them from Arizona, Ohio, Massachusetts, Canada. We've done Mexico. So they ship them to us for the destructive testing for bearing pads. The miscellaneous stuff tends to come from more southwest, but still people ship us stuff. It might be like rebar, like we've done rebar for the I-10 Broadway curve, tensile testing, yield testing, bend testing, when we're approved by like ADOT, or we'll get stuff from just miscellaneous manufacturers. Like back in the day, someone was having us peel the like cleared coating off of their printed photo books to see like how well the adhesion of these printed books were.
That's wild.
Yeah, like you had to grip onto a little piece of plastic, and they just wanted to know what the average strength to like peel that coating off of a photo was.
Yeah, right, that's cool. Yeah, so we get bearing pads from all over the world, right? I mean, we get, like you said, Mexico, Canada. We've had stuff from like the Middle East come in and everything, right?
Yeah, once like it was like UAE, I think, and then they came over and witnessed it while it was here.
That's awesome. How do you deal with the language barrier? Is it all? I mean, is there plenty of English going on right there, or are you using Google Translate a fair amount?
For the UAE, those guys like knew English like perfectly.
Okay.
Mexico, I've done our reports in Spanish and had to read all of their specs in Spanish.
Nice.
So I can read Spanish, but I just can't talk like well with it.
So we're like one of the only labs in the US that does what you guys do for bearing pads, right?
Yeah, so for full service, because you also have to have, as well as like the instrons, we have another hydraulic load test machine.
Big Blue?
Yeah, which we call like the blue press or big blue. Just a giant steel frame. Can load up to, it's like 2.2 million pounds. So we have that.
That's a lot of watermelons, man.
Yeah, so you can do non-destructive tests on these bearings, put the actual like bridge weight on them, and then do your visual inspection, or sometimes it's a deflection inspection. And then after that, we can take them and do the destructive tests. So there's like some places, there's other places that do the destructive tests on elastomers. A lot of them then also are like, there's a whole tire industry of people who do stuff for like tires, and the test methods are similar. But for like bearing pads, having like the load press and the destructive testing, there's maybe like, and I don't know if any of the other private companies can do it. There's DOTs that have labs set up to internally do it, and then there's colleges and universities. So we might be the only private company that can do both. Okay. There are like 2 other private companies that do at least the destructive, or like parts of them.
Gotcha.
Like, okay. So yeah, there's not a ton.
Yeah.
But once you include DOTs, it does like bump up the number.
All right. So let's back up here for a second, just for people that don't know. Bridge bearing pads, what are they there to accomplish? Like, what are they there to do for the bridges?
So they allow for the like structural movement. Like basically, in the course of a day, you have a bridge under sun. Everything heats up, it expands, and at night everything cools down and it contracts. So, and then you also have movements from like traffic going over bridges and stuff. Right, yeah. Bearing pads or bearings, because there's other types, sit typically on top of the columns, like the piers, the abutments, and then the beams that support the deck, the road, sit on top of them. So as the deck expands and contracts, you don't have like a solid connection. And for like, this is like longer, bigger bridges, like, cause sometimes for a short span, you might just have solid concrete, but longer, you then would get cracking. So basically the bearing pads just will allow that movement, that day-night cycle of movement.
Okay, so yeah, there's a lot of shear motion and tension going on in and out throughout the day and moving. And then also, the rubber's designed for different weather environments as well, right? So like you've got the stuff that goes up in Alaska.
Yep.
That's all going to be, rated to go down in the negatives. So we have a deep freeze.
Yes, we do. So yeah, so if you're up in like Alaska, they'll run tests that go into a freezer for 28 days.
How cold do they go to?
That they do -35 Fahrenheit. So then like Canada does -40 Fahrenheit. So they're around that range. Same thing. It'll be like 28 days. Down in Arizona, like in Phoenix, you don't have a low temperature test. No. You might have a quality assurance check that is like maybe at say like -25, but it's more just to make sure like the rubber meets standard QA. But up in the mountains, like if you're in Flagstaff, as you start raising in elevation and you get kind of colder temps, they'll do 7 to 14 day low temp conditioning. So it all depends on like, there's like a map of the US that designers and stuff reference that shows you like what your temperature zones should be designed for.
Okay, cool. So where could you talk about some of the bridges you've worked on?
Man, because I tried to think of even like number, and it's probably
you had to throw
tens of thousands.
Tens of thousands. That's impressive, man.
Because I'm like, if we've done like probably over 1,000 per year, and I've been here for like 13 years, I was like, that's a good amount.
Yeah.
But like big ones, the lead up to the Hoover Dam, because the Hoover Dam is huge, but like there's just the roadway going up has some like bridges that like when they redid everything, we tested those. And then I was trying to remember like other names. I'm pretty sure we did a bearing for like an entryway overpass into like Disney World. Like, so every once in a while you just see someone, you're like, hey, I recognize that place. Like we did recently the Broadway curve one, so like
when we're driving, phenomenal.
Man. Now when we're driving around, we'll be able to be like, oh, we tested these. Like,
Right.
we made sure that these like met quality requirements.
Yeah, that's super cool. And then we also did a lot of the rebar for the Broadway curve, and
Yeah.
I mean, you're getting rebar stuff from all around the Southwest right now, aren't you?
Yeah. So we'll
great.
do like tensile, like I said, tensile yield, and then bend test.
What's the biggest rebar that you've gone through yet?
Ooh, we can do up to a 14. I'm trying to remember if we've done one. Common, like we've done a lot of 11 bar.
11 bar?
Yeah.
All right. So for those, you would just go through, do your bends, make your candy canes,
Yep.
and then turn around, do your tensile pulls off of it.
Or like they give you like a long enough length where we have like saw, we can just chop off the length we need for the tensile test and like
Okay.
kind of run the tensile test and bend either like at the same time or from two separate specimens.
Yeah. Moving stuff along.
Yeah.
If you had to choose, what was the most like weird, complex test that you had to design and set up?
Setup wise, the most complex would be we did springs for a company out of New Jersey
Okay.
that are huge, that were like dampeners that they were trying to get a contract for. They would go under like a symphony hall to dampen vibration from subway.
Okay, gotcha.
That was like going.
Yeah.
So they were trying like setup wise was complex as we had riggers because like we're talking like their things were 10,000, 12,000 pounds. Yeah, so we couldn't lift them. But we could like design the programs and all that stuff. So, but their engineer like kind of designed fixtures. We helped to like show them like, hey, here are the machine sizes. Like here's
Yeah.
our clear openings. He kind of designed what he wanted for the fixtures, and we designed like the program. Like when he was like, hey, I want to record this. I want to move at this speed. I want this data. We set up the programs. We verified like, okay, that'll all fit. Scheduled everything, and then they kind of drove them down here, came down, witnessed the testing.
Gotcha.
So that was like the most complex thing we've done, just because it was crazy.
Yeah.
Like crazy big.
Mm-hmm.
But even small things can normally design and get through with like a simple fixture.
Yep.
So we do a lot of stuff that like just kind of like blends into what we test all the time. Like we've tensile tested like chains for the guys up the road who do vehicles.
Yep.
What is this chain that lowers at like a ramp brake
Yeah.
at? So figure out, okay, how do we hook up to the chain and how do we test that?
Yeah.
Or we've done hoses for like the oil and gas industry, like big diameter, like 6-8 inch
Yeah.
thick wall hoses that they just wanted a tensile test to, hey, let's see how they break.
Oh, yeah.
Yeah. So
Okay.
you get a whole bunch of different weird stuff.
I remember I think the wildest outcome that you had though were those airbags that you had coming through here for a little bit. Nobody thought that it was gonna rupture the way that it ruptured. So I think the first one, you didn't tell anybody what was going on. And all of a sudden, at least you didn't tell me.
Yeah, probably not like everyone. We set up like safety because like when we were running it, it was on our machine that's outside, so
Yeah.
we were able to like close the door, so it's like only like an inch.
Mhm.
Like, and I want to say the first couple, rather than just basically being an airbag that popped,
Yeah.
just developed like a leak that we could like tell.
Mm-hmm.
So like the first couple didn't make a noise. Yeah.
And then after that,
Yeah.
they went boom to where we were setting off car alarms down the street. In our back lot, they were all off. I was on the floor, just like ready to cry. It was.
It blew off the paint off the door. It was, so we had, after we were done with that, we did have to like repaint the door.
Nice.
Yeah.
Nice. Yeah. You got anything else, man? Anything else interesting?
I mean, yeah, but like I said, like it's kind of like, you know, doing like NDT, like you do a lot of different things. Like I find them all pretty interesting.
Right.
So
yeah.
like looking at custom stuff or trying to help people, like
Mhm.
like off the top of my head, we've tested like a monitor stand arm maker that like bolts onto a table.
Okay.
And I think they're over somewhere here in the valley. They just wanted to load test how much can this hold. So it was like develop something to hold your monitor stand, or like there's paneling that goes on the exterior of buildings, like made out of like copper and aluminum. Those guys sometimes have to do wind load tests, so they have fixtures that like vacuum suck their panels down, and we go witness, measure stuff,
Yep.
give them reports for that. Like that stuff's interesting. But the day-to-day, like the rebar, bearing pad stuff is like also interesting.
Yeah.
And then if you mix in doing GPR, you're gonna go into a lot of like weird like places because you do a lot for like tenant improvements. Someone's moving into an office and they want to, hey, we're putting desks over here. We want to have like a floor box, so a concrete guy comes, cuts holes. So we scan, make sure the concrete's clear. And I've been all over like inside of places in the valley from like.
That's the cool thing about actually all of our departments. All of us, I mean, we do plenty of work in the lab.
Yeah.
But we also get the chance to go outside. We do stuff outside. We go to job sites and do projects out there like the GPR. And you guys go and witness. You can do pull-out tests on anchors and everything. So I mean, it really kind of rounds out the whole thing. You're not just a lab technician. You become like the full service technician for the mechanical side.
Yeah.
Which is cool.
Yeah, we interact pretty well. Like try to each department supports the other departments.
Oh yes.
One way or another.
Yeah. Yep.
So those are always interesting too, because normally that then is like a change up from your normal day.
Yeah, that's great. All right, well, hope you guys enjoyed it, and we'll see you next time.